Adding polynomials, objective of this lesson to add polynomials. Before we start adding polynomials, we need to take into consideration two formulas, two area formulas. And the first area formula we need to know is the area of a square, which is s squared, and the area of a rectangle, which is length times width. Okay? These two area formulas become the foundation of algebra tiles. Algebra tiles make us model adding and subtracting polynomials. Okay, but let's add polynomials first. Let's represent polynomials with algebra tiles. You can use the concept of an area model to model monomials. A model of a monomial can be made using tiles drawings like the one shown below, and these are the tile drawings. Okay, this is unit tile because you have the dimensions of this square 1 by 1, which is a 1 by 1 square, and that's the reason why the area of a square becomes important. This is a unit tile simply because the area of this square is 1 unit. Okay, the next model we're going to talk about, this is the x tile, the area of an x. Why is that? Because you have the dimensions of this tile, the length is x and the width is 1. Multiply those two, you end up with an area of x, and that's the reason why it's called your x tile. Okay, the third model we're going to talk about is the x squared tile. Why is this x squared? Because it forms a square and each side has a measure of x, and we know from here that the area of a square is s squared. So here we simply multiply x times x, we come up with x squared. So this is an x squared tile. And we get the opposite of these three models. Okay, the opposites of these three models, the unit tile is -1. Okay, the x tile is -x, and the x squared tile is -x squared. Okay, they're all colored red to indicate that they are negative tiles. Okay, now how do we use these models? Okay, let's use these models to create a polynomial. Let's use these tiles to model a polynomial. Let's say, for example, you have this model. Okay, if you notice, there are two x squared tiles, three negative x tiles, and four unit tiles, four positive unit tiles. Okay, so you know for a fact that if you have two x squared tiles, that is 2x squared, and you have three negative x tiles, that is negative 3x, and four unit tiles, that is positive 4. Simply combine all of them together, you end up with 2x squared minus 3x plus 4. Okay, so your algebra tiles basically model your polynomial. In this case, 2x squared minus 3x plus 4 is what is being modeled in your algebra tiles right here. Okay, how do we use this? First, let's talk about some definitions, and then we'll discuss how we use algebra tiles to add polynomials. Okay, let's talk about what a coefficient is. The numerical part of a monomial is called the coefficient. Okay, for example, 5x squared. Okay, the coefficient is 5. So the coefficient of 5x squared is 5, the numerical part of our monomial. Okay, another probably good example would be, let's say if I have 6x squared. Okay, talk about, we bring this up, and let's say I have the polynomial. Okay, let me erase that thing. Let's say I have the polynomial 7y squared. Okay, the coefficient of 7y squared is simply 7, because that is the numerical part. That is the numerical part of the monomial, 7x squared. Okay? So this becomes your coefficient. Another good example would probably be 3. Let's say I have 3x z y to the second power. Okay? Or let's make y second there in order. Y squared z. The coefficient of this monomial would be 3. Okay? So that's what a coefficient means. It is the numerical part of the monomial. Okay? When monomials are the same or differ only by their coefficients, they are called like terms. Okay? For example, 2x and 7x, negative 5x squared y, and 9x squared y are like terms. Why are they called like terms? Because look at this carefully. Their variables are the same together with their exponents. So variables and exponents are the same, x squared y, and they only differ by their coefficients. So it's 2x and 7x are like terms because they only differ by their coefficients. Negative 5x squared y and 9x squared y are like terms because they only differ by their coefficients. Okay, so those are called like terms. 6a negative 5b, 7a cubed b squared, 7a squared b are unlike terms. Okay, simply because look at their variables. 6a is a variable of a, negative 5b is a variable of b. They are unlike terms. Okay, in the same manner, even though 7a cubed b squared, 7a squared b have a and b as variables, their their exponents are not the same. This has 3, this has 2, okay, and look at b. b has 2, and this one has only 1. Okay, so these are not like terms, they are called unlike terms. Okay, like terms are represented by tiles that are the same shape and size. Okay, so when you talk about like terms, they're represented by tiles that are the same shape and size. So another definition, a zero pair is formed by pairing one tile with its opposite. Okay, meaning if you have a negative 1 tile and a unit tile, this is what we call a zero pair because a negative 1 plus 1 equals 0. Okay, that's why it's called a zero pair. Okay, the opposite of another tile. You can remove or add zero pairs without changing the value of the polynomial. So we are now given 4 guidelines. The first one is defining what a coefficient is, okay, which is a numerical part of the monomial. The second guideline is knowing what like terms and unlike terms are. Okay. Third guideline is knowing what zero pairs are, and finally, when you remove zero pairs, you will not change the value of the polynomial. Okay. Now, how do we use these to be able to add polynomials? Let's find out. We have the model below, which represents 2x squared plus 2x minus 4 plus x squared plus 3x plus 6. Why is it 2x squared? Because there are 2x squared tiles, 2x tiles minus 4 because there are 4 negative 1 tiles. Okay? And it goes with the same 1x squared tile, 3x plus 6. Okay. Now look at this very carefully, because once we start adding this, okay, it's we can combine our algebra tiles and have something like this. To add polynomials, combine like terms and remove all zero pairs. So in this case, how did we define our like terms? Okay, we define our like terms as terms in the tiles, okay, that are the same. Okay, so in this case we combine all the x squared tiles, we combine all the x tiles, okay, the unit tiles and the -1 tiles. Now if you notice, these the 4 negative ones and the 4 positive ones have been circled because they are 0 pairs, which means we can actually take this away and not change the value of our, okay, polynomial. Okay, and if we count the number of x squared tiles, okay, and we add them up, we have 3x squared and we have 5x tiles, and what remains is 2 unit tiles. So 2x squared plus 2x minus 4 plus x squared plus 3x plus 6 is equal to 3x squared plus 5x plus 2. And that's how you use algebra tiles to be able to add those two polynomials. Okay? Now,